Hello viewers, in today's class we are going to discuss some very important and conceptual problem from limits involving the greatest integer function, right? And this session is going to be very beneficial for the beginners. So here we'll solve or we'll evaluate some limits containing the greatest integer function, and we'll see how we can evaluate these limits by using the definition of greatest integer function. So let us take some problems one by one. So here we have the first problem in which we have to find limit x tends to 4 plus here the positive sign shows that we have to find the right hand limit of this function greatest integer of 1 minus x when x approaches to 4 from the right of x is equal to 4. So here we have x is equal to 4 and we have to find the right hand limit. So we are approaching towards x is equal to 4 from the right of x is equal to 4. So we'll take a point in the right neighborhood of x is equal to 4 such that this point is our point 4 plus h, right, where h is a very small quantity which is also known as infinitesimally very small. So here h is greater than 0, but it is very small and lying between 0 and 1. So let us take this limit as L. So what we will do, we'll first convert this limit in terms of this quantity h by taking x is equal to 4 plus h, right? So we are very near to x is equal to 4, so that this point is 4 plus h, right? And when x tends to 4, then h tends to 0, right? So now this limit can be written as limit h tends to 0. Now we are changing this limit in terms of h. So we have here greatest integer of 1 minus x. X can be replaced by 4 plus h. So we can now write limit h tends to 0, and we can solve this expression inside the brackets. So we have 1 minus 4 minus h. So this is the limit h tends to 0, and this is 1 minus 4. So this is minus 3 minus h, right? Now see, here we have the expression minus 3 minus h inside the brackets. So now to move further, we cannot directly substitute h is equal to 0 here, right? So what we will do, we'll make use of the definition of greatest integer function. So the definition of greatest integer function says that if we have greatest integer of x is equal to n, where n is some integer, then this x is greater than or equal to n but less than n plus 1. So this is the definition of greatest integer function. So now here we have minus 3 minus h. Now see, 3 plus h, this quantity 3 plus h is always greater than 3, but it is less than 4, right? So 3 plus h, because h is a positive quantity, and when we add h to 3, then 3 plus h is slightly greater than 3, but it is less than 4. So what happens to minus 3 minus h? So if we multiply this inequality throughout by a negative sign, we can easily see that minus 3 minus h is greater than minus 4, because the direction of the inequality get reversed, and here we have less than minus 3, right? So minus 3 minus h is greater than minus 4 and less than minus 3. So now we have limit h tends to 0, and by this definition, see, minus 3 minus h is greater than minus 4. and the greatest integer function says that the bracket of x is equal to greatest integer less than or equal to x, right? So here the greatest integer of minus 3 minus h is minus 4, right, this number. So here we do not have any term containing h, so this is simply minus 4. So the value of this limit is negative 4. So now let us consider the second problem. So here we have limit x tends to 0 minus. So this negative sign shows that we have to find the left hand limit of this function when x approaches to 0. So here we have x is equal to 0, and now we are approaching towards x is equal to 0 from the left of x is equal to 0. So here we have to take a point which is in the left neighborhood of x is equal to 0, and this point is 0 minus h. So now we'll take this limit as L, and we'll substitute x is equal to 0 minus h. So when x tends to 0 negative, then h tends to 0. So now writing this limit in terms of h, we can write L is equal to limit h tends to 0, and we have greatest integer of 2x, right? So here we are taking x is equal to 0 minus h, which is simply minus h. So we have minus 2h here, and in the denominator we have negative of h. So as we have stated earlier that h is infinitesimally very small, but it is always greater than 0 but less than 1, right? So now see, here we have a term inside the bracket that is the negative of 2h. So when h is greater than 0, then negative of h is less than 0, right? And here we can see that this quantity that is negative 2h, it lies between minus 1 and 0. So we can obtain this inequality by multiplying this inequality by a negative 2. So when we multiply this inequality by negative 2, we'll get 0. Here we get 0. Then we the direction of the inequality get reversed, and here we have minus 2h, and here we have minus 1. So minus 2h, it lies between minus 1 and 0. So here we have minus 1 and here we have 0. And minus 2h, it lies somewhere between minus 1 and 0. So by definition of greatest integer function, the greatest integer of minus 2h should be equal to minus 1. So now we can write limit h tends to 0, and here we have negative 1 over minus h, right? So this is the limit h tends to 0. Here these negative and negative get cancelled. We have 1 over h. Now see, when h tends to 0, 1 over h tends to infinity, right? So here we have infinity. It means this limit does not exist. Now let us consider the third problem. So here we have limit x tends to minus. Again, this negative sign shows that we have to find the left hand limit when x approaches to 0, and the function is greatest integer of x, right? So let us take this limit as L, and here we have x is equal to 2, and we are approaching towards x is equal to 2 from the left of x is equal to 2, and the point in the left neighborhood of x is equal to 2 is 2 minus h, right? So now we'll take x is equal to 2 minus h, and when x approaches to negative, then h approaches to 0. and as usual h is infinitesimally very small, and it lies between 0 and 1. So now transforming this limit L in terms of h, we can now write limit h tends to 0, and here we have greatest integer of 2 minus h. So now let us concentrate on this term, that is 2 minus h, right? So see, 2 minus h, since h is greater than 0, so when we subtract h from 2, then we'll get a number which is less than 2, but it is greater than 1. So since h is positive, so whenever we subtract any quantity, any small quantity from 2, then 2 minus h is greater than 1, but it is less than 2, right? So by definition of greatest integer function, this 2 minus h, it lies between 1 and 2, right? So the greatest integer less than or equal to 2 minus h is equal to 1. So we can write greatest integer of 2 minus h equal to 1. So now we have limit h tends to 0, and here we have greatest integer of 2 minus h as 1. So now we have simply greatest integer of 1, and from the definition of greatest integer function, we can see that whenever we have any integer inside the brackets, then the greatest integer of this quantity is the integer itself, right? So here we have limit h tends to 0, so the greatest integer of 1 is simply 1, and this is equal to 1. So the value of this limit is equal to 1. Now let us consider the fourth problem. So here we have limit x tends to 3 positive. So this positive sign shows that we have to find the right hand limit of this function when x approaches to 3 from the right of x is equal to 3. So here we have x is equal to 3, and we have a point in the right neighborhood of x is equal to 3, and this point is very close to x is equal to 3. So this point may be taken as 3 plus h, right? So we can take this limit as L. So we can take x is equal to 3 plus h, and as usual h is infinitesimally very small quantity, and it lies between 0 and 1. So now when x approaches to 3, then h approaches to 0, right? So now we can rewrite this limit in terms of h. So we have L is equal to limit h tends to 0, and we have greatest integer of x minus x over 3 minus x. So x can be replaced by that is 3 plus h, and then we have here 3 plus h, and in the denominator we have 3 minus 3 plus h, right? Now see, here we have greatest integer of 3 plus h. Now see, 3 plus h is slightly greater than 3 because h is positive, right? H is greater than 0. So whenever we add any quantity, small quantity to 3, then 3 plus h is slightly greater than 3, but it is less than 4. So the greatest integer of 3 plus h should be equal to 3, right? Okay, so now we have limit h tends to 0, and this greatest integer of 3 plus h may be replaced by 3. Then we have minus 3 plus h, and here we have 3 minus 3 minus h. So this is limit h tends to 0. This is 3 minus 3, and here we have minus h. This is 3 and 3 get cancelled. Here we have minus h, so this is limit h tends to 0. 3 and 3 get cancelled, so minus h over minus h. So this is limit h tends to 0, and here we have 1, right? So this is equal to 1, right? Because here we do not have any term containing h, so we can omit this limit notation. So the value of this limit is equal to 1.